Hashtag 5G to 6G hardware evolution long-form tutorial script. You're thinking about 5G like it's the future. Wrong. The future is already here, and it's called 6G. And in the next 8 minutes, I'm going to show you exactly how the hardware is evolving to make it happen. I'm TechNavigator Pro, and this is what nobody's telling you about the shift from 5G to 6G. Let me be transparent with you right from the start. 6G isn't some distant sci-fi dream anymore. According to 3GPP's latest technical specifications in Samsung's 6G Vision white papers, we're already in the hardware development phase. The chips, the antennas, the infrastructure, it's all being built right now. And if you want to understand where tech is going, you need to understand this transition. Here's the problem most people face: they see 5G and 6G as just numbers. Like going from iPhone 14 to iPhone 15. But the hardware evolution? It's fundamentally different. It's a complete reimagining of how data moves through space. Let's break down what's actually changing in the hardware. Current 5G infrastructure uses millimeter wave frequencies, that's 24 to 100 GHz. You can find this in your carrier documentation and FCC filings. These frequencies are fast, yes. But they have a critical weakness: signal degradation. Rain, buildings, even your hand blocking the antenna, 5G struggles. The hardware has to compensate with massive MIMO arrays. That's multiple input, multiple output technology. Basically, more antennas crammed into smaller spaces. Look at Qualcomm's Snapdragon X80 modem documentation, you'll see arrays of antenna elements stacked together. That's 5G's solution to a fundamental physics problem. This is where 6G hardware gets wild. 6G operates in the terahertz spectrum, 300 GHz to 3 THz. According to research from Huawei and Nokia's Bell Labs, terahertz frequencies offer exponentially higher bandwidth. We're talking data rates in the terabits per second range. Not gigabits. Terabits. But here's the catch: terahertz waves are incredibly fragile. They're absorbed by water, by air molecules, even by dust. The hardware has to be completely different. Traditional antennas won't work for 6G. Researchers at MIT and Samsung have been developing metamaterial antennas and reconfigurable intelligent surfaces, or RIS. Instead of passive antennas, these are active, programmable surfaces that reshape how signals bounce and propagate. Imagine looking at a traditional antenna diagram versus an RIS unit. The RIS looks like a grid of thousands of tiny programmable elements. Each one can adjust its phase and amplitude in real time. This is critical hardware. Without RIS technology, 6G would be dead on arrival. If you're finding this valuable, hit that subscribe button. We post tech tutorials daily that break down exactly what's happening in the tech world, and I don't want you to miss the next one. Here's something most people miss: 6G hardware isn't just about antennas and frequency. It's about intelligence built into the silicon itself. According to Intel's latest processor roadmaps in Qualcomm's AI research division, 6G modems will have dedicated neural processing units embedded directly into the chip. Why? Because terahertz signals are so fragile that traditional signal processing can't handle them. AI has to predict signal degradation, adapt in real time, and optimize beam steering automatically. The hardware has to think. This is advanced, but stay with me. Traditional 5G uses electronic circuits to process signals. 6G is moving toward photonic integrated circuits, PICs. These use light instead of electricity to transmit data within the chip itself. According to research from Nokia's 6G white paper and Cisco's photonic studies, this reduces power consumption dramatically while increasing processing speed. Imagine looking at a traditional semiconductor chip versus a photonic chip. The PIC has waveguides instead of copper traces. Light travels through these waveguides instead of electrons flowing through wires. 5G consumes massive amounts of power. 6G hardware has to be radically more efficient. New developments include dynamic power scaling, where the chip adjusts its voltage and frequency based on actual demand. Per the latest documentation from ARM and TSMC, 6G chips will use 3nm fabrication technology with power domains that isolate different functional blocks. you'll see thermal management that's active, not passive. Some research prototypes from Samsung already show temperature sensors integrated directly into the modem die. Here's a practical hardware shift: 6G won't abandon existing infrastructure. According to FCC and ETSI documentation, 6G hardware will operate across multiple frequency bands simultaneously, sub-6 GHz, millimeter wave, and terahertz all at once. This requires multi-band transceiver architecture. The silicon has to switch between these bands seamlessly, with different antenna systems feeding the same processing unit. It's elegant and complex. 6G brings new security challenges. According to NIST's latest standards and Qualcomm's security research, 6G modems will have dedicated hardware accelerators for quantum-resistant cryptography. These aren't software implementations, they're actual silicon blocks designed specifically for lattice-based encryption algorithms. Why? Because traditional RSA encryption could be broken by quantum computers. The hardware has to be quantum safe from day one. Now let's talk pro tips that separate people who understand this from people who don't. First, start paying attention to which companies are leading 6G hardware development. It's not who you think. Yes, you have the obvious players: Samsung, Intel, Qualcomm. But look at the partnerships. Look at who's collaborating with research institutions. Nokia is heavily invested. So is Sony and Panasonic. These companies are developing specialized components, RF front ends, packaging materials, thermal solutions that won't make headlines but will be absolutely critical. Second, understand that 6G hardware won't appear overnight. According to 3GPP timelines and industry consensus, we're looking at first prototype hardware around 2026 to 2027, with commercial deployment starting around 2030. The hardware evolution is gradual. 5G chipsets will improve with AI integration. New bands will open up. RIS technology will deploy in infrastructure. It's a progression, not a switch. Third, if you're in tech or interested in where careers are heading, the hardware specializations that matter most are photonic engineering, AI integrated circuit design, and materials science. The bottleneck for 6G isn't software. It's materials that can handle terahertz frequencies, packaging that can dissipate heat from densely packed photonic circuits, and manufacturing processes that can produce RIS panels at scale. The hardware evolution from 5G to 6G isn't just an upgrade. It's a fundamental rethinking of how we move data through space. From passive antennas to intelligent surfaces. From electronic circuits to photonic integration. From fixed frequencies to adaptive multiband systems. This is physics meeting engineering at the bleeding edge. Remember, technology can feel overwhelming, but our job here is to help you navigate your tech journey with confidence. Understanding 6G hardware isn't about memorizing specs, it's about seeing the pattern, understanding the direction, and knowing where the industry is heading. If this breakdown helped you understand 6G hardware, subscribe to TechNavigator Pro. We break down complex technology into clarity. Every tutorial. Every day. New subscribers, welcome to the channel. You've just navigated one of the most important tech transitions of the decade. Let's keep going.